In our last video, we talked about the probability of either one event happening or another event happening. And the bottom line was if we say either event A or event B, either one would count as a success, then we could take the probability of just A and the probability of just B and add them together. But here we need to pause and talk about mutually exclusive events. Now, we talked in our last video about two different examples. In the first example, we had a bag of 20 marbles, and we looked for the probability of drawing either a red marble or a yellow marble. And the way we solved it is we said, well, what's the probability of drawing a red plus what's the probability of drawing a yellow? We added them together and we got 8 out of 20. But in our other example, we said that we have a deck of cards, 13 cards of each suit, and between the 4 suits, that means that you have 4 cards of each value. 4 times 13 is 52. So the probability of drawing either a queen or a heart would be the probability of drawing a queen plus the probability of drawing a heart minus the probability of drawing the queen of hearts. Why did we have to have this minus term in the second example with the deck of cards, but not in the first example with the marbles? Well, that has everything to do with mutual exclusivity. Mutually exclusive events cannot happen together. It's impossible. So you have event A and event B. Either A happens or B happens. There's no way for them to happen at the same time. These are called mutually exclusive events. There are other events that are non-mutually exclusive. I'll show you a couple of examples of those in just a second. But our first example of drawing marbles from a bag is mutually exclusive. Why? Because when you draw a single marble out, there's no way for that marble to be both red and yellow. It's either red or yellow. It cannot be both at the same time. All right. Another example, rolling a die is mutually exclusive. Why? Because when you roll a die, you cannot get a 3 and a 5 at the same time. Either you get a 3 or you get a 5. One die cannot be both at the same time. Suits in a single card are mutually exclusive. If you draw a card, could I have that card be both a heart and a spade? No, I can't. It's either a heart or a spade or a diamond or a club. Those are 4 mutually exclusive events. They cannot happen at the same time. But suits and values on cards are not mutually exclusive. Why? Because a card can be both a queen and a heart at the same time. Okay? So when we're talking about cards, specifically suits and values, those are not mutually exclusive events. Well, when 2 events are mutually exclusive, like the marbles or the dice, they can't happen at the same time. So we say, well, what's the probability of A happening and the probability of B happening at the same time? They can't happen. So that probability is 0. But if 2 events are not mutually exclusive, queen and hearts, they can happen at the same time. So the probability of A and B is not equal to 0. All right, let's step back, look back at the 2 events that I showed you earlier, but I'm going to add one thing to the marble example. Probability of drawing a red or a yellow marble will be the probability of a red plus the probability of yellow, so 3 out of 20 plus 5 out of 20, minus the probability of a marble being both red and yellow. Okay, that term is in there. We have this term of 2 events happening at the same time. We're going to insert that in there. But what's the probability of red and yellow happening at the same time? 0. It's mutually exclusive. So when we saw it earlier, we didn't see that minus 0 out of 20, but it was there. It really was there. We could just ignore it since it was 0. But since it's mutually exclusive, it doesn't matter. It still gives you 8 out of 20. Whereas with the deck of cards, Queen and Hearts is not mutually exclusive, which means that the probability of Queen and Heart is not equal to 0. Therefore, that term cannot be dropped. But if you want to go full, complete, do the full formula, just always include that minus probability of A and B, and then that probability will be 0 if it's a mutually exclusive event.